Happy morning! Narito ang kabuoang presentation ni DR.RHODORA ROMERO ALDEMITA dito sa naganap na conversation with the media para sa status ng Philippine Ag-Biotech sa kanyang global status of agricultural biotechnology, including Biotech Crops and the pipeline of the Philippines.
Of agricultural biotechnology, including Biotech Crops in the pipeline. So you see Romero Aldemita, Ma'am Ola.
Saya kami ngayon kasi we're back face to face. The last time that we had media encounter or media forum was online, and it's more exciting because now a presentation on the science of biotechnology, what is at stake, what has been done before, because crop biotechnology. What we are facing, why we need biotechnology. This is now the problem on high global population. We are tasked, especially our plant and food producers are tasked to double food production by 70%. We also have a problem on climate change. We are now feeling the effects of climate change. Did you know that there was a flood in Las Vegas 3 days ago? And that was the first time that it happened, and it is a desert. So yung climate change, so there are places where rain used to be not there, like what we have in Mindanao. It wasn't that bad before in Mindanao. Now Mindanao is a place where typhoons and hurricanes come. And so our climate change calendar, when are they going to plant? When are they going to harvest? And also, the climate change also affects the food production. Even a single 2-degree increase in temperature or 2 farmers need to know what's the current planting dates. And also, we have food insecurity because of so many things that happen all over the world. We have wars, we have internal problems politically in the countries, just like what happened to Egypt, which still is recovering. We have a problem if there wasn't enough importation, because of course, if you cannot plant in your country, you intend to import. Pero ang nangyari, even importation was not allowed. So, nagutom ang mga taga-Sri Lanka. And it's because there are several factors that affect this. It's the political will, and then the appreciation and knowledge of the new technologies for the farmers. And lastly, we have currently, this is data in 2019, 828 million suffering. But now it's more than a billion hungry people all over the world. So the problem that we are facing is to get to Sustainable Development Goals number 2, which is goal to have zero hunger in 2030. And that cannot be done with the usual business as usual food production. That's why I said we need to increase food production by 70%, baka nga 100% na at this point. So what we are going to do now is to rationalize or give a reason why we need to do biotechnology. Those are the many challenges that global community face, and biotechnology is one of the ways by which we can target or head-on respond to those challenges. So we have here the DNA, which is common. This is now the basis of life in every organism is the DNA, and all of the organisms have the same sequence of DNA. It only happens that each of the organisms target organism. This is what happened to our biotech corn. The very famous biotech corn, which was started in the Philippines in 2002, approved, and then planting started in 2003. Microorganism, a gene from Bacillus thuringiensis, was transferred to corn. Diba? So imagine that you can just splice a DNA, get it out, put it in a vector, or in a venue, or in a vehicle. Put in a vehicle or a vector, and then You can transform or you can. Corn borer was the second one. So BT corn was made resistant to the European corn borer and the Asiatic corn borer. And it started also in the Philippines in 2002. In different countries, it started in 1996. So we can see that in some of the data as I provided to you. So currently, what I said, since 1996 to now, these are now the potentials, or we have actually felt these benefits already. So we have a lot of transgenic or GM or genetically modified organisms that can help us fight diseases. You're familiar with our COVID-19 vaccines, the Moderna, the Pfizer, Janssen, and they're all based on biotechnology. Of course, we have the conventional vaccines, which were Sinovac, and I think one from Russia, that are attenuated viruses. But the other ones, which were developed fast enough so that it can help the global population, those are DNA or mRNA-based vaccines. So that is a very good example. We have increased yield, we protect the environment through biotech. We improve our crops, making food more nutritious, just like what we have in the Philippines, the golden rice, and we help the industry because we produce much more raw materials. So currently, this is now the data of 2019. We're still trying to put together the 2022 data. Because during the COVID, there was a very difficult time. We had a hard time getting funds and getting data. So we're now striving to get both money and data. But suffice it to say that by 2019, since 1996 to 2019, compared to the industrial countries. That's why our developing countries are more into biotech, because we need the food. We need the benefits that can. These are, we know that weeds are a very problematic, it's very problematic in many field crops. When you plant, you have to make sure that the weeds are not there so that it's not going to cover your plant. So what do farmers do? They spray herbicide to kill the weeds, and then they can plant. Now, conventionally, if you don't spray again, those weeds will grow again and will cover your crop. So what do farmers do? They pull out the weeds, and so the soil becomes exposed, and then the topsoil will become dry, and when rain or when heavy winds come, all the topsoil will just go away, and our plants will just die because of exposure of the roots to the elements. So what did scientists do? So they produce Biotech Crops, which are herbicide tolerant, so that after you spray, to my many farmers. So it has gone up the fastest. We have soybean and corn, and also we have canola, and then with that was insect resistance. But then you see that insect resistance did not go as far. There are still a lot of problems with insects, and we know that we have the European, the eggplant fruit and shoot borer. We have the European and the Asiatic corn borer. And so our scientists and our farmers became more knowledgeable, and they know that putting two genes together in one crop will give higher benefits to the farmers, because you are targeting two problems already, the weeds and the insects. And so the stack traits, meaning crops with two traits, have already been adopted the highest, and it looks like our prediction is that it's going to go higher than herbicide tolerance. And we have a lot more traits incorporated in all these crops. Our region, the Asia Pacific, and then the US and Canada, and then Latin America and Europe. We have two countries in Europe which are planting Biotech crops, Portuguese and Spain. And in Africa, we have 6 African countries and increasing. We have heard of new countries in Africa who are starting to grow biotech crops. So these are now the insect-resistant traits in crops. So when it started, it was only corn, soybean, canola. Now you can look at the different crops which have insect-resistant traits. So maize, cotton, potato, soybean, sugarcane, rice, poplar, cowpea, eggplant, our eggplant, and tomato. So this is around 307 events. And you can look at this at the ISAAA website. We have a GM approval database at our website. It's a database, and you can it's for free. You can just open it, look at it, and see what are these traits. What are because insect damage comes from the roots to the stem, and then sa kernels, sa grains, and then when you do storage, they are also affected by insects. So you can see there in the database what are the traits and which are the insects that they are targeting. And then we have herbicide tolerance traits. So this is what I was telling you about. So we have them in these crops, 361 events. And these are now the herbicides which are available. And herbicide tolerance are for glufosinate ammonium, Roundup, you're very familiar with Roundup, and many others. And then many different abiotic stresses, other biotic stresses. So these are now the diseases, nematodes, and virus resistance. We also have that in the database, and you can look at it. So the Philippines currently has this in store for us. So we start with the approval for food, feed, or processing in these crops. So what do you mean by processing? So we import raw material without the embryo, so that they're not going to be planted. They're just coming here, they're going to be processed as oil from canola, as oil from maize, and then you can see that once rice is grounded very well, you destroy the embryo, so you can just kind of plant it. So it's also important. We import a lot of rice. But there's the GM rice that is available in the market are the herbicide tolerant rice as yet. And then, so we are now, we have approval for cultivation. So we had it in 2002. That's what I said for biotech corn. And then we have the golden rice, which was approved for food, feed, and processing in 2019, and for cultivation in 2021. So our group in field rice and Erie are now preparing for deployment to different parts of the Philippines. We also have approval for BT eggplant. This is for food, feed, and processing in 2021, and cultivation in 2022. And just last week, we have an approval for BT cotton for propagation already. So that was August 24, 2023. You can put that in your news. So that's the latest we have. And we're very happy that the Philippines is still maintaining its #1 position in Asia Pacific, #1 in regulation, and #1 in the number of crops approved for propagation. And we're happy about that. And then, so this is now the potentials. So I'm just going to be very fast here. I think I'm using a lot of time. So we have, So we now have, because of biotechnology, we have gained productive, and because in 1996 to 2018, this is how much food we were able to produce because of biotech. And this just comes from maize, GM maize, soybeans, cotton, and canola. But by 1996 to 2020, this is the recent data published by Branham Brooks in 2022, we have now 1 billion tons of crops produced by biotech throughout the world. And for sustainability, conserving biodiversity, what do you mean by that? We do not need to denude forests, we do not need to reclaim lands to produce more crops or to increase food production. We can use biotechnology, and we can save 231 million hectares. Meaning, You don't have to plant 231 million hectares more to get this amount of production, because our production is high enough due to biotechnology. So we're saving 231 million hectares. This is a data of 2018. And for 2020, so 1 billion tons of food produced will require 23.4 million hectares of land. This, if you multiply this by 10, so of course, it will be 234 million hectares. We're saving about that much. If you would like to get to the original article, you can just go to PG Economics, and this is Graham Brooks, spelling Brooks, and this was published last year in 2022. And for sustainability, we mentioned about not spraying too much anymore, not cultivating or pulling out the weeds anymore, so you save on labor, as well as you save on fuels because you don't spray as much anymore. So these are the savings. For 1996 to 2020, reduction of 748.6 million kilograms of, or 7.2% of the area planted to GM crops. So these are the reduction of insecticides and products from fossil fuels that gained. If you don't have biotech crops, you have to use as much. But with biotech crops, you don't use anymore that much. So you save on global reduction in pesticide use, so we have better environment, and reduction in emission of carbon dioxide. Why carbon dioxide? In very big lands, just like in the US, you have to use fossil fuels in order to spray. And so they use a lot of methane, or they use a lot of gasoline. But now with biotech crops, you don't use that anymore. So you save on 23.6 billion kilograms carbon dioxide. And this is equivalent to removing 15.6 million cars off the road. Marami na yan, 15.6 million cars off the road. Yung pollution is also reduced. And finally, we have to check on this contribution to the alleviation of poverty and hunger. So with that amount, our farmers gain $3.76 in extra income for each extra dollar invested. So meron ka ng profit nito. Pero if you put that in bigger context, in 2020, 18.8 billion net farm level economic benefit, or $103 per hectare. And so this is for global farmer income benefit of $112 per hectare. So these are totals. And this will help alleviate 17 million farmers all over the globe. And this is in the Philippines, the data for us. Since we have been planting herbicide-tolerant maize in 2026 to 2020, we have accumulated all these benefits by our farmers. And from insect-resistant maize, this is how much we also have increased profits by our farmers. Again, to summarize what we have in the Philippines, we have these crops approved for import for food, feed, and processing. And then we have biotech maize planted by 673,000 farmers in 875,000 hectares in 2019. These are the benefits in these years. And as I said, these are what we already have approved for food, feed, processing, and for planting. Very happy Filipinos here. Now we move to another section of biotechnology, which is genome editing, gene editing. So when we say conventional, so we just have plant A, you cross with plant B, you get a new plant. And for new breeders, this will take 10 to 25 years. For rice, it takes 15 years to get one new plant or new seed developed. For genetic modification, which is what I have just discussed, you get a source of the gene, just like what I said, you can get it from bacteria, You put it in your target plant genome, which in this case is corn, and then this is a trial and error. You have to develop or regenerate or get a lot of transgenic corn and then identify which is the best one to move the breeding forward. So you have to select a very few lines from thousands of seedlings. So because it's random, genetic modification. But now for gene editing, this is more precise. So this has been started about 10 years ago. And so we have a lot of activities, R&D activities for gene editing. So what is that? What is gene editing? You can just splice or activate, you splice a few fragments of DNA, and that means you lose the trait attributed to that sequence of DNA. So it's either you deactivate unfavorable traits, you lose it altogether because you just cut it, and then you join the DNA together. So you cut and then you join. This is just like mutation, which has been with us since the 1970s. My master's degree was in mutation. So I know that you have to do a lot of sampling to get to your desired mutant. But in gene editing, you know, as soon as you know the sequence, the genomic sequence of the crop, you can identify, ayun, ang titirahin ko, sigurado ito. Pag tinanggap yung sequence na to, itong crop na to will have a new trait, which is better. This is also what happens to humans. This is what's happening to gene editing or gene therapy. Have you heard about gene therapy? So the human genome, people now know if you have a cancer, they know where to look. They know what sequence of DNA they have to look. And then you can just have radiation or chemotherapy just for that mutant sequence. So the same is for crops. You have to make sure that you're using the sequence of genome and you target that undesirable sequence. And another one is you also have enable a beneficial characteristic. You can insert a little bit, maybe around 19 base pairs, and then you can also gene edit that, or if it's a very big sequence, then it's genetic modification already, but it is targeted. You know where it went. It's not as random as genetic engineering. So gene editing is just here, and we have a lot of activities, R&D, and in order for you to be guided on what they are, I'm offering you the ISAAA website. We have this book, which has been published in 2021. This is a primer, introduction, and you can download it for free. And then, so we have also gene editing resource. We publish a lot of materials on what's happening with gene editing, the products that are coming up, and then which are the ones going to be in the market. So the first gene edited, so it has increased oleic acid, and this is soybean, and it has been marketed since 2019. This is developed in the US by Calyxt. And then, so these are now, I'm just going to provide you some gene-edited products that are already in the market and which are coming up. So this is now the Gaba tomato, approved for commercialization in Japan. So it has been on sale in Japan since 2021, I think. And this is says there, to develop, to help lower blood pressure. And we had a speaker on that, a scientist who developed this, and they were saying that you can just eat 5 tomatoes and you're okay. But I think they're still looking at the dosages. Of course, baka naman sobrang bumaba, ano. So it depends on the physiology of the person. And these are now the upcoming gene-edited products. This is for increased yield. So we have camelina with 5% increase in oil, canola, which are shorter and easier to harvest. And then we have, yes, this is resistance. So we have here cherry tomato resistant to venal motovirus, wheat resistant to powdery mildew. This is going to be fast because these are just in the pipeline, they're still not out. Maize tolerance, drought tolerance, and lower lignin content so that you can feed the silage to your livestock because lignin is very difficult to digest. So lower lignin is better for our livestock. We also have barley with delayed germination. Sorghum with fragrance to make food smelling good for liquor and vinegar brewing. Potato with decreased cold-induced sweetening, reduced acrylamide formation, and prevents food wastage. And so, with applications of gene editing since 1996, you see, 2021, these are now the crops which were gene edited. Some of them are already out there. We still have to trace where they are. So we have rice, tomato, maize, soybean, wheat, potato, canola, and barley. If you want to have an updated data on this, you can go to the International Seed Federation so that you can look at the crops and the traits which are gene edited. And then for the countries, we have here China leading the pack of R&Ds for gene editing, and sequentially, up to Australia. And in the Philippines, what do we have? So currently we have just approved, not just, but I think it was in March, when we have our regulatory body in the Philippines, Bureau of Plant Industry, have already determined that this Cavendish banana is gene edited and is safe for planting and consumption. So it's already in the Philippines. For R&D, we have high lycopene tomato and low phytate corn being developed at the Institute of Plant Breeding. And at Erie and Phil Rice, of course, they are improving rices with soft grains, resistance to diseases, and improved yield. Okay? So, what are the potential benefits of agriculture of biotechnology? This slide sums it all. So, it's for farmers, consumers, and the whole planet, with all the gamut of traits. For weed management, this is resistance, drought tolerance, quality improvement, and enhanced nutrition. So I think we have speakers on the regulation in the Philippines. I'm not going to talk on this anymore. And which institutions are working on biotechnology. You can see it here. And then, so just a food for thought. This is how corn was being developed and utilized back then, from 1970 up to 2002. This is a global data. But because of biotechnology, we have seen the increase in yield. And with genome editing, we are expecting by 2030, we are expecting this much of harvest. And this is what biotechnology can contribute to sustaining food production and for developing the SDG 2 goals of the United Nations. So with that, thank you very much for your attention.
Alright, so naintindihan natin itong global status of agricultural biotechnology kasama ang Biotech Crops and the pipeline for the Philippines at kung ano yung mga ginagawa ng ating mga scientists sa ibang bansa at ang kanilang mga pag-aaral na para sa hinaharap ay talagang sana may apply nga naman natin ito dahil sa nais na lumago pa ang ating ekonomiya at yun nga na yung lalo na sa pamamaraan ng agrikultura at yung mga mais natin ay lumago para bumaba ang presyo nito kapag po ay lumaki ang production. At kapag lumaki ang production ay dumami nga yung ating mga makikinabang hinggil dito sa pagbaba ng presyo ng ating mga crops at kung ito ay tangkilikin para lumaki. So, malaking tulong ang biotechnology para nga lumaki ang production nito at gumanda yung ating mga ani at maging safe sa ating kalusugan. Alright, so, yan po si Dr. R.HODORA ROMERO ALDEMITA. At isusunod naman yung the revised regulatory system for Biotech Crops and the Philippines. So, yung sistema naman nito at mga rules, kung yung revise, kung paano yung ginagawa Yun po ay tatalakayin ni Miss Maria Loreli Agbagala, Head ng National Committee on